Hi guys, today we are going to be talking about the metadata that is collected as part of the survey performance tool. Metadata is data about the data. That is, we collect information about the executable, the system, and the environment for the upcoming run. This metadata is collected just before the run. That means its collection doesn't interfere with the performance of the run in any way. It's just a bit of collection that we do before kicking off the run. The metadata that survey collects is quite extensive, and you may not want to collect it with every single run. In that case, the survey config files allows you to disable metadata items. Now, to be clear, the data is still collected before the run, but then after the run is completed, survey goes through and it deletes all the data that you have indicated in the config file, so that data will not be included in your final results. This metadata collection can be done without actually using the survey runtime collector. So if the performance of your application is absolutely critical and you don't want to waste any of the even minimal resources needed to run the survey runtime collector, you can still use survey to collect metadata. Now, why would you do that? Well, if you're going to be doing a research study or any other series of runs in which you may be concerned about any sort of anomalous data or particular runs that just don't fit with the rest of your data set, then the metadata can give you really important clues as to what may have caused any issues. Now, we collect three main categories of metadata. Executable data contains information directly concerned with the executable. Hardware data contains information about the machine used to perform the run. System data contains information about the operating system and the environment of the run. Now let's go into some more details. The executable data includes the command line used with the run, the executable path, and the checksum of the executable. This just lets you know if anything changed in the executable, even if the name of the executable stayed the same. A list of all of the libraries linked to the executable, and a checksum of each library. So just like the checksum of the executable, it's possible for the library to change during a system upgrade, and yet the library name does not change. The launch time and the end time of the run. This gives you an overall runtime, even if you don't use the runtime collector. The survey command used for the run and the survey config file. If the executable is run inside a Git repository, we also collect the current commit of the repository. Together, all of this gives you a very full picture of the run executable. Now, if you also use the survey runtime collector, and that is turned on by default, after the run, we use the data gathered from that collector to add several more pieces of information about the run to the metadata. This includes the number of processes, ranks, and threads in the run, the process IDs, rank numbers, and the thread numbers, the map of hosts to ranks and processes, and then to threads, the affinity information collected both before and after the run, and the program type the survey uses to determine whether it was an MPI program, an OpenMP program, whether it was single or multi-threaded. Now, if you don't use the runtime collector, the metadata shown here in this slide isn't collected. Although some of the data here can be inferred from other data that is collected. The next category of metadata that we collect is related to the hardware. We run lscpu to collect data about the machine CPU, or CPUs. The free command gives us information about the machine's memory capability. DF collects data on any connected file systems. LSPCI gives us a list of devices connected to the machine. And the NUMA control command gives us information about the memory access connections. And this is related to the affinity data that is collected with the runtime collector. Please note that this data is only collected for the machine that surveys initially run on, also known as the root machine. If you are using a compute cluster as part of the run, normally all the other machines in the cluster are homogeneous and have the same characteristics as the root machine, but there could be some differences. The last category of data is system information. We collect the survey version used to perform the run, the initial node name of the machine, the username, information about the operating system and its version, the resource limit imposed on the user by the operating system. If the run was performed with Slurm, we run scontrol to get relevant Slurm data. The environmental variables and the values they were set to at the time of the run, and finally the contents of perf event paranoid. This is relevant to the collection of the PAPI CPU counter data. Now I'm just going to give you a quick example of survey and how you can view the survey metadata. Here I'm going to run the nbody application with survey. So survey mpi run -n2./nbody and just let it run. Okay, so the bottom line gives us the prefix. The metadata and the report file are always use that prefix. The metadata file would be called nbody-survey-metadata.json. And let's go ahead and take a look at that file. As you can see, the results of the metadata are in JSON format in this file, and we can just scroll through them. Everything that I mentioned in the slides before is in this data. The environmental variables take up quite a bit of space, so we're going to go ahead and skip forward a little bit. Okay. And then as you can see here, there is the final affinity data. So that's about it. Thank you so much for watching, and if you like this video and would like to see others like it, please hit the like button on your screen, and I will see you in the next video. Thanks a lot. Bye.